Bismillahirrahmanirrahim. Assalamualaikum. Welcome to my YouTube channel Diversity of Plants Zone. Before starting my today's video, I request you all to please subscribe my YouTube channel. Today's topic of my video is about introduction and classification system of Augustin Pyramus De Candolle. So let's start the video. First of all, I will introduce Augustin Pyramus De Candolle. Augustin Pyramus or Prime de Candolle was a French. He was born on the 4th of February 1778 and died on 9th of September 1841. So he was a Swiss botanist. René Louis Desfontaines launched de Candolle's botanical career by recommending him at a herbarium. Within a couple of years, de Candolle had established a new genus and he went on to document hundreds of plant families and create a new natural plant classification system. Although de Candolle's main focus was botany, he also contributed to related fields such as phytogeography, agronomy, paleontology, medical botany, and economic botany. Augustin Pyramus De Candolle, Augustin Prime de Candolle, 1778 to 1841, Swiss botanist, as shown in the figure. Next, I am going to discuss about biography. So he was born on the 4th of February 1778, Geneva, Republic of Geneva. Died on the 9th of September 1841 at the age of 63, Geneva, Switzerland. Nationality Genevan, then Swiss, 1815. Other names Augustin Prime de Candolle. He was known for the systems of taxonomy, principle of nature's war, awards Royal Medal, 1833. Scientific career include the fields like botany, agronomy, phytogeography. Author observation botany includes DC. Augustin Pyramus De Candolle. De Candolle originated the idea of nature's war, which influenced Charles Darwin and the principle of natural selection. De Candolle recognized that multiple species may develop the similar characteristics that didn't appear in a common evolutionary ancestor, a phenomena known as the convergent evolution. During his work with plants, De Candolle noticed that plant leaf movements follow a near 24-hour cycle in constant light, suggesting that an internal biological clock exists. Though many scientists doubted, De Candolle's findings, experiments over a century later demonstrated that the internal biological clock indeed exists. De Candolle's descendants continued his work on the plant classification, which include his son Alphonse and grandson Casimir. De Candolle contributed to the Prodromus Systematis Naturalis Regni Vegetabilis, a catalogue of plants begun by Augustin Pyramus De Candolle. Next, I am going to discuss about the Swiss botanist. Augustin de Candolle is considered one of the most important botanists of the 19th century. His major contributions were in the fields of plant classification and morphology, the study of form, and in the geographical distribution of plants. Candolle was born in Geneva and his early studies were in Switzerland. In 1796, he moved to Paris where he studied medicine and the natural sciences and where he often visited the Natural History Museum, which was the center for research. He came to know leading scientists of the day, including zoologist George Cuvier, 1769 to 1832, and the early advocate of evolution, which is also called Jean Baptiste de Lamarck, 1744-1829. These connections increased the Candolle's interest in biology to the point where he abandoned medicine and devoted himself to botany, focusing on the investigation of plants' texture. Candolle remained in Paris until 1808, when he was made chair of botany at the College of Medicine in Montpellier in southern France. From there, he moved back to the Switzerland in 1816, when he became chair of natural history and director of botanical garden at the Academy of Geneva. He retained these positions until 1835, and when he retired, his son Alphonse, also a noted botanist, took over his work. While at the Academy, Augustin Candolle created an impressive herbarium, a collection of dried plant specimens that continues to be studied by the botanists to this day. The primary focus of Candolle's research was in taxonomy, a word that Candolle himself coined. It refers to the theoretical study of classification of how organisms are sorted into categories. Candolle's work was influenced by that of the great French botanist Antoine Laurent de Jussieu, 1748 to 1836. Both favored a natural system of classification as opposed to the artificial system of Carolus Linnaeus, 1707 to 1778, who had created the first widely accepted classification system. In this system, a single feature, the structure of flower, was used as the basis of classification. Plants with similar flowers would be placed in the same category, even though they might differ greatly in other characteristics. A natural system, on the other hand, is based on decisions about all overall similarity, with many characteristics being examined and considered. Candolle was also influenced by the botanical work of the great German poet, which is also called Goethe, 1749 to 1832, who was an enthusiastic student of botany. Goethe argued that there was a general plan or form that underlie all the plant structure, with particular species being variation on this general theme. Candolle too saw unity underlying the diversity of plant form. He was also agreed with the Goethe that the parts of the flower were all related to the leaf form, that petals, for example, could be seen as the modified leaves. This idea was very influential in the 19th century and reflected an interest in finding a way to simplify or unify the study of the plants. Candolle studied many plant families and wrote books on such plants as lilies and cacti. He also published several impressively illustrated works, including one with paintings by perhaps the most famous botanical illustrator of all time, Pierre Redot, 1759 to 1840. In terms of the contributions to botany, Candolle's most significant work was called Prodromus, which ultimately ran to 17 volumes, several of which were written and published after his death by his son Alphonse. This work was description of whole range of plants and attempted to include all the known species. It presented information not only on classification but also on ecology, agriculture, and phytogeography, which is the study of how the climate and terrain influence the distribution of the plant species. This last area is where Candolle made his most original contributions, and he is considered one of the founders of this field. Next, I am going to discuss about his early life. Augustin Pyramus De Candolle was born on 4th of February 1778 in Geneva, Republic of Geneva, to Augustin De Candolle, a former official, and his wife, which is called Louise Eleanor Berea. His family descended from one of the ancient families of Provence in France, but relocated to Geneva at the end of 16th century to escape religious persecution. At the age 7, De Candolle contracted a severe case of the hydrocephalus, which significantly affected his childhood. Nevertheless, he is said to have had great aptitude for learning, distinguishing himself in school with his rapid acquisition of knowledge in classical and journal literature and his ability to write the fine poetry. In 1794, he began his scientific studies at the Collège de Genève, where he studied under the Jean-Pierre Etienne Watcher, who later inspired De Candolle to make the botanical science the chief pursuit of his life. Next I am going to discuss about his career in botany. So he spent 4 years at the Geneva Academy studying the science and law according to his father's wishes. In 1798 he moved to the Paris after Geneva had been annexed to the French Republic. His botanical career formally began with the help of the René Louis Desfontaines, who recommended De Candolle for work in the herbarium of the Charles Louis L'Heritier de Botila during the summer of 1798. The position elevated De Candolle's reputation and also led to valuable instructions from the Desfountaines himself. De Candolle established the first genus, which is also called Sanibera, in 1799. De Candolle's first books, which is called Plantarum Historia Seculentrum, 4 volumes, 1799, and Astragalogia, 1802, brought him to the notice of the George Cuvier and Jean Baptiste Lamarck. De Candolle, with the Cuvier's approval, acted as a deputy at the College of de France in 1802. Lamarck entrusted him with the publication of the third edition of Flore Française, 1805 to 1815, and in the introduction entitled Principes Élémentaires de Botanique, De Candolle proposed a natural method of plant classification as opposed to the artificial linear method. The premise of the De Candolle's method is that taxa do not fall along a linear scale, they are discrete, not continuous. Lamarck had originally published his work in 1778 with a second edition in 1795. The third edition, which bears the name of both Lamarck and De Candolle, was in reality the work of the latter, the former having only lent his name and access to his collection. In 1804, De Candolle published his Essai sur les propriétés médicales des plants and was granted a Doctor of Medicine degree by the Medical Faculty of Paris. 2 years later, he published Synopsis Plantarum in Flora Gallica Descriptrum. De Candolle then spent next 6 summers making a botanical and agricultural survey of the France at the request of the French government, which was published in 1813. In 1807, he was appointed professor of the botany in the medical faculty of University of Montpellier, where he would become the first chair of the botany in 1810. His teaching at the University of Montpellier consisted of field classes attended by 200 to 300 students, starting at 5 a.m. and finishing at 7 p.m. So, during this period, De Candolle became a close acquaintance of the Portuguese polymath José Correa da Serra, who was Portuguese ambassador to Paris and who circulated in an international network of thinkers ranging from the Briton Joseph Banks to American Thomas Jefferson and William Bartram, and the French scholars Antoine Laurent de Jussieu and the George Cuvier. Correa's endorsement of the idea of emphasizing similarity and symmetry in classifying plants influenced De Candolle, who acknowledged as much in his writing. While in the Montpellier, De Candolle published this Théorie élémentaire de la botanique, Elementary Theory of Botany in 1813, which introduced a new classification system and the word taxonomy. Candolle moved back to the Geneva in 1816, and the following year he was invited by the government of the Canton of Geneva to fill the newly created chair of natural history. De Candolle spent his rest of life in an attempt to elaborate and complete his natural system of botanical classification. Career in botany, De Candolle family home in Geneva, as shown in the figure. De Candolle published initial work in his Ragni Vegetabilis Systema Naturale, but after 2 volumes he realized that he couldn't complete the project on such a large scale. Consequently, he began his less extensive Prodromus Systematis Naturalis Regni Vegetabilis in 1824. However, he was able to finish only 7 volumes and 2/3 of the whole. Even so, he was able to characterize over 100 families of plants, helping to lay the empirical basis of the journal Botany. Although De Candolle's main focus was botany, throughout his career he also dabbled in fields related to botany, such as phytogeography, agronomy, paleontology, medical botany, and economic botany. In 1827, he was elected an associated member of the Royal Institute of the Netherlands. Next, I am going to discuss about his later life. Augustin de Candolle was first of the 4 generations of botanists in the De Candolle dynasty. His son Augustin Pyramus De Candolle, whom he fathered with his wife, which is also called Mademoiselle Taurus, eventually succeeded to his father's share in botany and continued the prodromus. Casimir de Candolle, Augustin de Candolle's grandson, also contributed to the prodromus through his detailed, extensive research and characterization of the plant family Pyperaceae. Augustin de Candolle's great-grandson Richard Amil. Augustin de Candolle was also a botanist. Augustin de Candolle died on the 9th of September 1841 in Geneva after being sick for many years. That same year, he was elected as a member of American Philosophical Society. In 2017, a book was written in French about his life, and one of the greatest contributions, The Botanical Garden of Geneva. Next, I am going to discuss about the legacy. He is remembered in the plant genera Candollea and the Candoleodendron, 7 plant species like the Eugenia and Candolleana or Diospyros Candolleana, and the mushroom, which is also called Sathirilla Candolleana. Candolle, a scientific journal that publishes papers on the systematic botany and phytotaxonomy, was named after the De Candolle and his descendants in the honor of their contribution to the field of botany. He was a mentor to the French-Mexican botanist Jean-Louis Berlandier and is credited with encouraging Marie-Anne Lebit to investigate the cryptogamic flora. De Candolle also had an unexpected distinction of triggering the adoption of prepaid postage in the canton and the city of Geneva in a long address which he gave to the governing council in 1843. This led to them issuing the Switzerland's second postage stamp, the famous double Geneva, later in that year. See also postage stamps in postal history of the Switzerland. Next, I am going to discuss about his classification system. De Candolle was the first to put forward the idea of nature's war, writing of plants being at the war one with another, with the meaning of different species fighting each other for space and resources. Charles Darwin studied De Candolle's natural system of classification in 1826 when at the University of Edinburgh, and in the inception of Darwin's theory in 1838. He considered the warring of the species, adding that it was even more strongly conveyed by the Thomas Malthus, producing the pressures that Darwin later called the natural selection. In 1839, De Candolle visited Britain and Darwin invited him to dinner, allowing the two scientists the opportunity to discuss the idea. Classification system. De Candolle was also among the first to recognize the difference between morphological and physiological characteristics of organs. He ascribed the plant morphology as being related to the number of organs and their positions relative to each other rather than to their various physiological properties. Consequently, he made him the first to attempt to attribute specific reasons for structural and numerical relationships amongst organs and thus to distinguish between major and minor aspects of plant symmetry. To account for modifications of symmetry in plants, in parts of different plants, an occurrence that could hinder the discovery of an evolutionary relationship, De Candolle introduced the concept of homology. Next, I am going to discuss about the chronobiology. De Candolle also made contributions to the field of chronobiology, building upon earlier work on plant circadian leaf movements contributed by the scientists such as the Jean-Jacques Dortius de Marin and Henry Louis Duhamel du Monceau. De Candolle observed in 1832 that the plant Mimosa pudica had a free running period of leaf opening and closing of approximately 22 to 23 hours in constant light and significantly less than approximate 24-hour period of the Earth's light-dark cycles. Since the period was shorter than 24 hours, he hypothesized that a different clock had to be responsible for the rhythm. The shortened period was not entrained, coordinated by environmental cues. Thus, the clock appeared to be endogenous. Despite these findings, a number of scientists continued to search for X factor, an unknown exogenous factor associated with the Earth's rotation that was driving circadian oscillations in the absence of dark and light schedule until the mid-20th century. In the mid of 1920s, Irving Bunning repeated De Candolle's findings and came to similar conclusions in studies that showed the persistence of the circadian rhythm in the South Pole and in a space. Lab further confirmed that existence of the oscillations in the absence of environmental cues. Next, I am going to discuss about the natural system of A.P. De Candolle. Augustin Pyramus De Candolle, 1778 to 1841. His views are expressed in his Theorie élémentaire de la botanique, 1813. He laid much stress on morphological characters and also recognized the significance of vestigial organs. The three generations of De Candolle collaborated for the preparations of monumental work Prodromus Systematis Naturalis Regni Vegetabilis, 1824 to 1823, in which the every species then known to science was described and classified. Synopsis of A.P. De Candolle's system of classification first includes the vascular plants with cotyledon, exogenous or dicotyledons, vessels arranged in a ring, and embryo with two cotyledons. It includes the flowers with perianth differentiated into calyx and corolla, perianth leaves in two series. Thalamiflorae, petals free on the receptacle. Cohorts 1. Carpus mani and stamens opposite to petals. Natural orders 1 to 8. Ranunculaceae, etc. Cohort 2. Parietal, placentation carpus, solitary or many connate. Natural orders Cruciferae or Violaceae, etc. Cohort 3. Ovary single, natural orders Carophyllaceae, Rutaceae, etc. Cohort 4. Fruit genobasic, natural order Semerubiae, etc. Caliciflorae, flowers perigynous, petals free or fused, ovary inferior or superior. Natural orders epigynous, flowers with gamopetalous corolla, Rubiaceae compositae. Coroliflorae, petals united, ovary superior. Natural order Acanthaceae, Asclepiadaceae, etc. Monoclamidae, perianth in one roll, plants with the carotid vascular bundles, cotyledon 1. It includes monocotyledons and Cycadaceae with the 27 orders. Next is plants without cotyledons, foliaceous, which includes mosses and liverworts. Non-foliaceous of unknown sexuality, which includes fungi and lichens, etc. If you like my video, please like and subscribe to my channel. Thank you so much. Thank you for your time and appreciation.